Meeting last week, we started looking at branching statements or conditional statements. We went through it, saw an examples that implement branching statements with user-defined function. Okay, so we'll look at that. We'll just briefly go through that example again, and then we'll go straight to look at loops. And then if we have time, we'll look at the numerical methods. We look at numerical methods. So without wasting much time, I'll switch to MATLAB. Then we look at the example on the sign function with the use of the if-else conditional statements. All right, so in our example, which we looked at in class, we're talking about the sign function, and that's the sign function is used to tell whether a sign is negative. So if you have a whole number, if the sign is a negative sign, it returns -1. If that sign is 0, or if that value is 0, it returns 0. And then if it's a positive value, it will return a sign, it will return +1. Okay, so we saw this example with the sign function. So sign into brackets, let's say -1, 2.3, bracket close. This will give us -1 because it is a negative, or because the sign to the value is negative. And then we saw the same thing. If the sign is positive, it will give us 1. And if the value is 0, it will give us 0. Okay, so the task was that we write a program using a function, preferably user-defined function, okay, to implement this same predefined or built-in function. So the question said that we first create an M file, so we create a script file. Okay. And the script file, like we always do, we comment your name, your ID is commented as well. And then what's the problem? What's the problem? The problem is saying that you should write develop a function. So a sign function that returns its arguments as -1, 0, and then 1. So in the code, we said that we are going to start with writing a function. Okay, so in writing the function, we start with a keyword function. Now, like I said, after you start a function, you end it. So we start and then end. Then you introduce the output argument. So SGN equals my sign. Okay, where my sign here is the function name. So my sign X, where the X is your input argument. So inside this function, we first introduce we first introduce a comment, okay, that returns the sign. Okay. It returns 1 if the sign is greater than 0. So we introduce that condition and say if x, okay, so the x is this value here. If the x is greater than 0, if the x is greater than 0, then it should output SGN, which is sign, is equal to 1. Okay. And then we end the if, so it's equal to 1. So what do? We save this function. We save it. So in saving it, you click on the save symbol, save sign, or the save icon. And like I said, your function name is always the same as your file name. Okay, anytime you write a function, the function name is the same as the file name. So once you see the file name, you don't change it. You always make sure it's the same as the file name, and then you press save. Okay, so by so doing, that is going to save your function. Okay. So now let's call the function inside the command window and see our output. So to call the function, we start with the function name. So the function name is my function, my sign. So my sign, so I've copied it and pasted it, my sign into bracket x. So x is expecting me to enter the value. So if I enter 23, 23 is a positive whole number. So it's going to give me the answer of 1. Okay. But if I enter, let's say, negative 23, okay, it doesn't give me any response because I've not captured that inside my function. Okay, so we are going to use the else if to handle that because we have multiple conditions in, in this program. Okay, so I'll go down and say else if x is equal to 0, then it should output sign, or it should output 0. So SGN equals 0. Then the last one, if it's not 1 and it's not 0, it will be negative 1. Okay, so the last one will say sign equals negative 1. Okay. So this is what we have here. So with the equal to, we said you use a double equal to find the relationship, not a single one. It's a double equal to. And then we end our statement. Okay. So this is the first condition. If x is greater than 0, then our value is 1. That's a positive number. If x is equal to 0, then it should give us 0, or it should return 0. Else, if x is none of the above, it's not greater than 0, it's not equal to 0, then automatically it is less than 0. So we said that with the else, you don't assign your condition to it, okay, because it's obvious that if it's not greater than, it's not equal to, then it will be less than. So we don't need to write the condition there. So we just go straight forward and then return -1 if it is less than 0. So once we've done that, save your work. Then let's go back and implement, call the function for -23 again. And then this time around, it's giving us -1. If we call the function my sign, and we put in there 0, it gives us an answer of 0. Okay, so this is how the branching or the decision making or the conditional control structure work, with the use of the else, the if else, sorry, the else if, and then the multiple conditions, which is the else statement. Any question before we move to look at the loops? Any question? So what we've just done is a recap from last week. So now let's look at the loops. So if you get your handouts, there are some more examples in there. You can go through it. There are more examples. So this example is using the switch case. So this is how that also works. Check for error. All right, so let's look at loops. Okay, so let's look at loops. So loops are also what we call the control structure. So we've looked at the sequence one, the sequence control structure. We've looked at the branching, selection, or the decision-making control structure. And then now we want to look at the loops, or loops are also known as repetitive operations, okay, in your code. So it says here that one of the strongest attributes of a computer is its ability to do fast repetitive operation on a set of data. Now, as programmers, we use this feature through loops when we want to repeat certain parts of our program over and over again. Okay, so for instance, we say we want to calculate the sum of all elements in an array A. We want to calculate the sum of all elements in an array A. Okay, so how do we do that? The loops helps us to perform that function. So it said we use the brute force approach. This can be done by the brute force approach. You would have said A1, A2, A3, A4, all the way to AN. Okay, now this approach is time consuming. Okay, in the sense that you have to do it one after the other. Okay, now similarly, you can write it in this other way, where you have A is equal to 0, A is equal to some A is equal to some A, sum A plus A1, sum A plus A2 in that order. Okay. Now, when you do it that way, it's going to take a longer time. Okay. So let me just explain what it means, what is happening there. So I'll close this function and clear this command window and just show you. So we have an array. Okay, so let's say an array A is equal to let's say 1, 2, 3, 4, 5. So we have 1, 2, 3, 4, 5. Okay. Now with this, if we want to sum, okay, perform a sum of them, we say sum A is equal to A into brackets 1 plus A into bracket 2. Okay, that gives us 3. Okay, so it's adding this 1 and 2. Okay, so if you want to continue, you say sum A into bracket 3, okay, plus sum A into bracket 4, A into bracket 4. Okay, that gives us 11. So 1 plus 2 is 3, plus 3 is 6, plus 5 is 11. Okay, now if we have our value of A, okay, going all the way to N, all the way to N. Okay, that's what the lecture note is suggesting. All the way to N. Okay, what it will mean is that, let me write it this way so we can follow. If we have our values, A, 2, 3, 5, and this goes all the way to N. We don't know the last number. Okay. What will happen is that when we come here, we have to keep adding and keep adding until we reach the last number, which is A into bracket N. Okay. A into bracket N. That will be the last number. Okay. And this is the brute force approach. So you realize that you go all the way adding and adding, and you might never end because your value of N is not known. Okay. Then there's also another approach, which goes by this method. Okay. So let's look at how that is also implemented. So in this approach, you have your A, let me clear the workspace. You have your A to be this, okay, and you say your sum A is equal to 0. Okay. Now sum A is now 0. So sum A is equal to sum A plus A into bracket 1. Okay. Now what this is doing is that we know our value of sum A to be 0, as we can see from here. Okay. And then A1 here is 1. Okay, so it's going to add 1 to our 0, which will give us 1. Okay. Then, so that will be so that will give us 1. Then we are going to add some A to A2. Okay. So now our value of sum A, our new value of sum A is now 1. Okay, so sum A is now 1 plus A2, and A2 is 2. So 0. Okay, so we press enter. When we press enter, oh, sorry, sum A is 2, not 0. Sum A is here, which is 2. Okay, so 2 plus 1 will give us 3. Okay, so this is 1, 2, 3, 4. So we come again, we repeat the code again, and we say sum A plus A3. Now A3 from our value here is 3. Okay, and our value for sum A is, this time around, our value for sum A, sorry, our value for sum A is 3, which is this one. So 3 plus A3, A3 is also giving us 3. Okay, so that will give us 6. So our new value for sum A is 6, which is this one. Then, then we have the next one, which is sum A plus A4. Sorry, A4. So we know sum A, the current value of sum A is 6, and our A4 is 5. So 6 plus 5 will give us 11. Okay. So when I click on, when I press enter, you see that's what it gives us, the new value of sum A as what? 11. Okay. So this other approach, imagine you have to add up to 100 numbers in your array. That means you have to be repeating this 100 times. Okay, which ideally is not the best approach as a programmer. Okay, or it's not the best approach for writing your programs. Okay, it's not the best approach. So what do? We use what we call loops to handle situations like this. We use loops to handle situations such as this. Okay. So how can we do that? Okay, so the formula is given here. It's very simple. So we say that first, your sum, which is equal to 0. Okay, and then we introduce what we call the for loop. So for I equals 1 to n. Okay, can we all see that? I equals what? 1 to n. Okay, so in the previous context where we had 4 numbers, all we could have done is say that for I equals, instead of the n, we put 4 there. That means it should repeat this statement 4 times. Okay, 4 times. Why? Because of this loop function, which is called the for loop. The for loop. For loop. Okay. So we are saying for I is the counter, we call it the we call it the counter variable. Counter variable. Okay. So for I equals to 1. So we are starting the count from 1 to 4. And we know what the column is used for. 1 to 4. Okay. So that's 1 to 4. I think the example we had was A is equal to square bracket 1, 2, 3, and then 5. Okay. So we are performing the count. These are 4 values, 1, 2, 3, and then 4. Okay. So this 1, 2, 3, 4 we see here, that is what is going to be represented inside our for loop, depending on the number of times we want to count. So if we are doing this computation 100 times, all we have to put here is 100. Put 100 there. And then this statement will be repeated 100 times. Are we all here?
Yes, sir.
Okay. So let's go back to our code and then try this and see what we can get. So instead of doing all this, okay, what I'll do is I'll go into my M file. Into my M file. And then let's say the usual approach. So I'll just do that quickly, your name, your ID, and then the problem. So the problem here is to calculate the sum of elements of an array A. So if A is given by, let's say, we had A to be 1. Jefferson, please stop writing on the screen. Undo whatever you've written on the screen. Jefferson. Thank you. 2, 3, and then 5. These are our values for our array. So let me separate it with comma. So inside our program, I'll just say A is equal to 1, 2, 3, and 5. And then we will say that sum A is equal to 0. So we are saying that the first value of sum A is equal to 0. So just like we did over here, okay, sum A is equal to 0. Then now we introduce the for loop. We now introduce the for loop. Okay, so how do we introduce the for loop? We just say for. Now, anytime you bring the for, you should also have to end it. Okay, so for I equals 1. 1 to what? 4. So the column 1 to 4, because we have 4 characters, also, sorry, 4 numbers in our array. So from to 4, we say sum A equals sum A plus A. This time around, instead of saying A into bracket 1, A into bracket 2, A into bracket 3, and 4, now we've used II over here to represent those counts from 1 to 4. So all you do is you pick this II here and put it, becomes your counter variable, and put it in the bracket for this. Okay, so what do we have here? Instead of writing this command and repeating it one after the other, okay, all the way, repeat.
Let's exercise patience. I'm sure maybe some problems at this.
Say it.
All right, sorry, my internet went off. I'm sure my part-time people will be talking about, say, you said your internet. Derek, are you there?
Sam, yeah.
We are listening.
Oh, don't worry, they give the signals to you.
All right. You know when you say your internet is having issue, I always come back and tell you to watch the video. So, all right. So let's go on. Okay. So what I was saying is that instead of rewriting this command, just look at how
your
many
face,
times.
so we are not seeing your screen.
Oh, sorry.
Your screen is not there.
Can you see the screen now?
Yes, sir.
All right. So like I was saying, instead of you writing the code and writing the commands one after the other, so instead of saying sum is equal to sum plus A1, then you go and we come again and do plus A2, plus A3, plus A4. Imagine we have all the way to N. So you do it up to, if it's 100, you have to write this command 100 times, okay? Instead, the loops makes your entire code very short. We are repeating this code 4 times. So just introduce your for loop for II equals 1 to 4. Then you come and put your II here to repeat these numbers. So at the first instance, where you have II here, at the first instance, II here will be 1. Then it will repeat it again when II is 2, and when II is 3, and then when II is 4. So at the fourth instance, it's going to end. Okay. So this is what we call loops. It just repeats the code. So instead of writing some long redundant code, you just use your for loop with just one statement in there. And then it repeats it based on the condition you set there, the number of times you set here. So if you want you to repeat it 100 times, I'll just put here 100 and make sure my value in my array are up to 100 so that it repeats it 100 times. Okay, so let me change it back to 4 and then let's save the work. So this is not a function. Okay, it's not a function, so I can give it any name. So I can say for loop. So after saving it, I'll just run it. Let me clear my workspace. Sorry, clear the command window and then run it. Because it's not a function, I don't need to call it. So I just have to run. So you can see here, run for loop. So sorry, it's not displaying the answer, but if you can see here, you see that what? The sum is equal to 11. Okay, so let me just clear the workspace and then run it again so that you can see. So clear workspace. and then run. So when I run it, you can see that what a sum is equal to what 11. Okay, it's equal to 11. Or equally, I can come to the end of my statement of my for loop and put the display this sum A. Okay, so when I run it, this time it will display what 11. Okay, it's displaying it here. So for loop is 11. So if I change this to 100, or let me change it to 10, and then introduce my values. Oh, sorry. One, two, three, 4, 5, 6, 7, 8, 9, 10. So this is 10. So with this, when I click on run, okay, what does it do? It shows me all the values and gives me the answer as what? 44. Gives me the answer as 44. So it's adding all the numbers. Are we all here?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So this is how simple loops are. This is how simple loops are. Okay. So let me take an example of a program we've written already. Okay. Let me see from here. Let me take one example from here. So I think area of a circle. Let me see if, okay. So this is a program. Let me use something that's okay. Looking for something I've done with you guys. Let's see. All right, so let's use this example. So let's assume, so this is a function to calculate the area of a circle. So it says enter radius of the circle, compute the area, and then print out. So I'll run this function. Okay. So I'll call this function, or when I run it, it says enter the radius of the circle. So the radius is 5. Okay, then it tells me what the area of a circle with radius 0.5 is 78.5. Okay, so this is something we can all do. Are we all here? We all agree. This is a question we can all code we can all write, okay, to calculate area of. Now imagine the question goes like, calculate the area of 10 circles. Are we all here?
Yes, sir.
Yes, sir.
So
we are
the
following.
initial one was a circle. Now it says 10 circles. 10 circles. Okay. Now you know that this function here, just as we ran the function, gave us what? The value for a circle. So we want this statement to be repeated 10 times. Okay, we want this function to be repeated 10 times. So how do we do it? We just say, just before the start of the function, we can say for I equals to 1 colon 10. Okay. 1 colon 10. We end the function and then end the loop. Okay.
Sir, please, we can't hear you.
Can you see the screen?
Yes,
Can you
sir,
see
we
what
can
I'm
see this.
doing?
Yes, sir, we can see this.
So we want this code to repeat 10 times. Okay, so I've taken the function off and I'm going to run this. Okay, so when I click on run, you can see the first instance. It's asking me to enter the radius. So all that I've done is just put for I equals I is to 10 and then just end it. Okay, so for I equals I to 10 and end it. So it's asking me the radius. So if the first circle has a radius 2 or radius 3, I enter it, it calculates it, then it's showing me what? Enter the radius of the circle. Okay, but let me just edit this code quickly, okay, so that you will not see it the way it's appearing here. So rather, we are going to put \n here. So the \n, let me do it twice so that it will give us 2 lines. So I run the code again. Okay, so let me clear everything and let's start afresh so you can follow what's happening. So over here, you can see, okay, I've added a double / here so that it will give us a space. So I run the code. A code is what calculates area of circle. Calculates area of a circle. All right. So calculate area of a circle. So if I enter the first radius, which is 3, it gives me the area of a circle when the radius is 3. Then I have another radius of, let's say, 6. It gives me the area of a circle when the radius is 6. I have another one, which is maybe 3.5 or 3.4. It gives me, okay, so this is going to repeat 10 times. So far, we've done 3. So let me just enter any value. Okay, so I think we've done this 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's left with the last one, the 10th one. Okay. So the last one, maybe I'll say a radius of 1. Okay. So you can see that after entering the 10th one, which has a radius of 1, automatically the code ends. Okay, it ends by bringing me the double greater than sign. But initially, when I started, it had to read 10 times. Okay, you all get it? Are we all here?
Yes, sir.
Yes, sir.
Okay, so the loops
Yes,
is
sir.
straightforward. It's nothing difficult. So if they say, okay, you've written a program to find the volume of to compute the volume of a cylinder, and now you are being asked to do it for 10 different shapes, 10 different cylinders. All you do is just introduce your for I equals 1 to 10 on top of it. Sorry for that. So you've written your program to calculate maybe volume of a cylinder, okay, and you want to repeat it 10 times. Just introduce your for loop for I equals 1 to 10. Okay, so whichever number you are given to indicate the number of times you repeat it, just put that number here and then add your n to it. So you have something like this. Okay, then it's going to repeat this statement for you 10 times, or depending on the number of times you want to repeat it. Are we here? Are we all here?
Yes, sir. Yes, sir.
All right.
Yes, sir. We are.
So that's it on the loops. So loops is straightforward. I wouldn't spend much time on it. When you get your handout, you see examples in there. You can
Sir,
try
please,
your
I have a
hand.
question.
Yes, you can go on with your question.
Yes, please. What if maybe you have 10 circles with the same radius and you want it like straight away one time? It's not now you are coming to punch one by one the radius. So you want it to give you the answer like for each radius, each circle, one by one by one by one by one, without having to punch the radius one by one to 10.
And so that even makes it straightforward. You know that the radius is 10. So if you do it for one, it's the same as you calculating the radius for a circle. Do you get me? So there's no point repeating it 10 times since you know that all the values are the same, all the radius are 10. So when you use just one calculation, you are able to tell the area of all the circles.
Okay.
We are doing this in the context where the values differ. You have different values.
Okay.
That is when you do that. Now, even with the loops, you can also have a loop where your it says in the four loops, the loop expression can also take other forms. In general, the loop expression can be any matrix. Okay, then the MATLAB assigns one column of the matrix to the index variable and executes the statement within the body for that loop successively for as many columns there in the matrix. Okay, so you can do something like this. Okay, so let me just copy this, run it quickly, and see what it's talking about. So he's saying that it can be done within different contexts. So let me introduce a new script and just do this. You put here diffs II. So when I run it, you can see it's showing me the column. So 1, 4, that's the first time. Then 2, 5, that's the next column. And then 3, 6, okay, at the next column. So it shows you, like what it's saying, it said, MATLAB assigns one column of the matrix to the index variable and executes it. So it's like we are having you're having something like this, a matrix A, and the matrix is giving you 5, 9. Sorry. The matrix is giving you 1, 2, 3, 4, 5, 6. That's what we have in this example. So it's saying here that it's going to pick one column and assign an index to it. So let's say 1. The next column, 2. And this next column, 3. Okay, if you want to write it in this form. All right. Okay, so that's it for the functions. Sorry, that's it for the loops. There's also what we call the while loop. Okay, this is how the while loop also functions. Okay, so with that one, perform the count and then there's an increment. So the while is only taking the condition. Then it will do +1 to it. Okay, perform +1 and it will increase in that order. So there are some examples here. Finding standard deviation of some numbers. So you can try them out. So to find the standard deviation of some numbers, then it gives you how to use the loop. Okay, from 1 to n. So if the numbers, you specify the numbers and there are 5 numbers, your n will now be 5. Okay, so first it says enter the array of numbers. So I enter the array of numbers. If there are 6 numbers, then n is equal to length of the number. So n will be equal to 6. So if n is equal to 6, the sum of numbers, it will perform it just like the example we saw. Okay. Then the square of the sum. So the square of the sum is you saying what? The number squared. Okay, so whatever number you have, it will square it, then add it to the sum. Then after that, we find the average. So the average is the total of the sum of the numbers divided by the length of the number. Then we find standard deviation. So the equation for finding standard deviation also is written here using the square root function. This square root function is inbuilt. Okay, it's a square root function and it's inbuilt. It's inside your program, so you just use it. And then there's a standard deviation. You output the mean and then the standard deviation. Okay. So there are a couple of examples here. All right, so I'll end on the loops. There are more detailed examples, but I'll not go through that. And then, like I said, also the chapter 7, I'm going to skip it because of time. Okay, so that we look at algebra, numerical methods in algebra, numerical methods in MATLAB. Okay, so this will be our last topic on MATLAB. So I'll introduce it today. Next week, after the mid semester, we'll look at examples on it, and then maybe we'll look at some past questions on this, and then we'll link it to plotting. We'll link it to how to perform plots. So this is our last but one topic for the SEM. All right, so numerical methods in MATLAB. Now, talking about numerical method, we are focusing more on linear algebra, the algebraic expressions or equation, linear set of equation. Okay. So it said one of the most common linear algebra problems is the solution of a linear set of equation. For example, consider the set of equation. We have the value, we have our matrix A, and then we have our X, and then it's equal to Y. Okay, so in this equation, you know the values for Y, you know the values for A, and then you are told to find X. Because X has been given as X1, X2, X3. Okay, so how do you use MATLAB to perform some of these equations? Okay, that is what we are looking at. Then we look at roots, to perform roots, find roots of values, and then what we also call polynomials. Polynomials. All right. So he said the above equation define. Okay, sorry, this is define. Define the product of n times n. Okay, n times n matrix. That's like a 3 by 3 matrix A. And then the n by 1 vector. So this is a column vector, n by 1 column vector X as being equal to n by 1, another column vector again, Y, which is this. Okay. Now the existence of solution to the above equation is a fundamental problem in linear algebra. Moreover, when a solution does exist, there are numerous approaches to finding the solution, such as the Gaussian elimination, the LU factorization, and the direct use of the inverse, okay, of A. It is beyond this scope, okay, or beyond the scope of this test to discuss this analytical and numerical issues of matrix algebra. We will only demonstrate how we can use MATLAB to solve this problem. Okay. So we are not coming to do the computation. We are just using MATLAB to solve this problem. So with this equation, if you want to solve it, we can do it in this form, okay, where we have this our equation, and then we have y. So we have x. Okay, we want to find x. So x is equal to the inverse of a times y. The inverse of a times y. Okay, the inverse of a times y. So this is how we compute the inverse of a. Okay. Then another way we can also do this is by using the left division property. Left division. So we said the division is 2, the forward slash and the backslash. The forward slash is the right division. The backslash is the left division. Okay. So it's just like we saying that you have your value ax equals y. Okay. So if you want to find a, x, okay, x is equal to y divided by a, right? Is that what you get?
Yes, sir.
Yes, please.
Okay. Now this y divided by a, the a is already a raised to the power 1. Okay. So if we do the inverse, we are going to have y times a raised to the power -1. Okay. So that is what it's explaining to us. Okay. Especially this part. Okay. As what we are being given here, the inverse of a times y. Okay. Then similarly, we can do it in this form and say a. So we are going to get y, x is equal to y divided by a. Okay. Now, if you are writing this using the forward slash, we would have had y by what? A. Okay. But it doesn't work that way. Okay, you can't divide, you can't use the right division to handle a matrix and a column vector. Okay, rather, you use the left division. So a forward slash y, okay, to perform that computation. So let's look at the example we have here and see how what we can get for the value of y inside our MATLAB. So I'm going to use the command window to just try this quickly. Just a quick one. All right. Let me close this. So it's giving us a is equal to it's a 3 by 3 matrix. So 1, 2, 3, then semicolon 4, 5, 6, semicolon 7, 8, sorry, not 78, 7, 8, and then 0. Okay. That's our A. And our X is given by, so we are given a column vector. So our X is given by, let me say X1, then semicolon, X2, semicolon, X3. Oh, sorry. Okay, let me use variables A, B, C to represent them and see if that should work. Okay, sorry. Let's made a little mistake. Okay. So we have our value of A and we have our Y. Okay, we have A and Y, we don't have X. So it's X that we want to find. So our Y being a column vector, we have 10, semicolon, 11, semicolon, 12. Okay. So this is our value. So we are going to find A, or our X should be equal to A inverse times what? Times Y. Are you all with me?
Yes, sir.
A inverse
Yes,
times
sir.
Y. This is our Y. This is our A. And we've been told that we can write that by using the inverse function, which is inbuilt. So inv into bracket A, okay, and then we multiply it by our Y. Is that clear? So we'll come here and then we'll say X is equal to inverse of A as in capital A, star Y. So now you can see the value of X. So it's giving us negative 9.3, negative 9.6, and then negative 0, 0, 0. Is that clear?
Yes, sir.
Okay, so we can use MATLAB to perform some of these linear algebra equation. Okay, then let's just try the the left division also and see if it will give us the same answer. So you see the answer is the same. Okay, so when we use the inverse and when we use the left division, we get the same response. Okay. All right, so let me just go through some functions with you and then we'll continue next week when we meet face to face. So some of the functions we have when it comes to linear algebra, matrix especially, we have the Cholesky, Cholesky, factorization is the function, then the matrix condition number, fund A, to find the determinant of a matrix, det A, to find the eigen vectors, eigen value, vectors of the eigen value, to find the diagonal, and so on. The inverse, which we just do, the LU to normalize a matrix, the norm of a matrix, the rank value, the decomposition, shell decomposition, SVD values, and so on. These are all functions in there. Then when it comes to data analysis, which is also numerical methods, so you want to find the maximum value. So maybe you have a matrix X, and you want to find the maximum value in the matrix. They use max. You want to find the mean, you want to find the median, you want to find the sum. Okay, so you want to sort the matrix, okay, and so on. Find standard deviation. These are all inbuilt functions in your code which you can use. Okay. So our next face-to-face meeting, we will look at polynomials, especially looking at roots and how to fit curves, plot curves. Okay, then we will be done with chapter 8. Then we have one last topic which has to do with Microsoft Excel. All right, any question from what we've done? Any question?
No, sir.
All right. So if there's no question, next week we would have our mid-semester exams. We have our mid-semester exams. Yes, you have a question?
Sir, please, where are the questions coming from?
Oh, won't you even relax for me to finish what I'm saying? By the way, the questions are coming from space.
Where? Sir, please, where?
Sir, can you please repeat your question?
Please.
Okay, please.
All right, can I speak now?
Yes, sir, you can speak now.
Okay. So the question will cover, like I said, the handouts. Please mute your microphone. The feedback is bad.